Hi dear boys, previous lesson we studied combination and we said that we will use combination for probability, or in probability we will use combination, but combination has also another usage, or we can also use combination for binomial expansion. Remember binomial expressions. Binomial expressions were algebraic expressions with two terms. And binomial expansion is the simplifying or simplification of binomial expressions with a power. For example, as you see in here, x plus y is a binomial expression. It has two terms, x and y. But if you want to expand x plus y to a power of n, or if you have any binomial expression like x plus y to a power of 10, and if you multiply it 10 times, if you multiply x plus y 10 times by itself, the result will be the expansion of this binomial expression. We can also solve binomial expressions by combination. But first, we said that we can expand a binomial expression in different ways. One of them is Pascal's triangle, using Pascal's triangle. Look at this figure in here, as you see here. There's a mouse, and it moves from left to right, from a circle to another circle. And the numbers inside each circle shows that in how many ways the mouse can come to that circle. For example, from this circle, there's only one way to this circle, or from this one to this one. But for this circle, we have two ways. One of them is from here, from this circle. The other one is from here. And also from the third one, in here, we also have three ways. One is like this from here, if it moves from this 1, 1, 1 and goes to the 3. It can also go from 1, 1, 2 and then 3. This is the second way. And from this one to this one, and from this one to 2, and also goes to 3. This is the third way. So we can say that the numbers inside the circles shows the number of ways that the mouse can arrive to that circle. If it's 6, it means there are 6 different ways that this mouse can arrive this circle. If you turn around this circle, you will get another figure like this. Look at here. This is, let me show it a little larger, like this. If you turn around this figure downside, this shape downside, you will get these numbers like this, like a triangle in here, which starts with this side. Is also all of these sides starts with 1 and also ends with 1. And there are another numbers inside these triangle. And there are rows which start from 0, and we also have the sum of these numbers, for example 1, 2, 4, 8, 16. As you see, the sum of all of the rows is a power of 2. But how about these numbers which are written inside this triangle? First of all, we should say that this triangle is called what? Pascal's triangle. As for the first time, Pascal, a mathematician by the name of Pascal, find this triangle. So we call this triangle, or he called this triangle, Pascal's triangle. But what's the properties of these of this triangle? What's the property of this triangle? The first property is that each row begins with 1 and ends with 1. As you see, 1, 2, 1. Or this row, the fifth row, 1, 5, 10, 10, 5, 1. And the sum of two consecutive terms in a row gives us the number in the term between these two terms in the next row. For example, look at here, 15 and 21. Let me explain by two examples. 21 is the sum of 6 and 15 in here. Or 15 is the sum of 10 and 5, which gave us 15. Or 70, as you see in here. 35 plus 35 give us 70. You can find any other numbers below these numbers by adding the other two terms in previous term to get the new number between these two terms. The next property is first row is the 0, or the row starts from 0, not from 1. And you can get, or you can find, or you can complete, because it's continuing up to infinite. You cannot complete it, but you can find the other entries in the Pascal triangle by adding the two terms in previous row to get the new term in the next, between them and the next row. What's where do we use this Pascal triangle? Let's study that. That we can solve, or we can expand, the binomial expressions using Pascal triangle. And also we studied the Pascal triangle, or how can we find the Pascal triangle. We studied this. Now let's see how can we expand the binomial expressions. First of all, I should say that the entries, or the numbers, as you see in here in Pascal triangle, are the coefficients in binomial expansions. What does mean the coefficient in binomial expression? What's the row? Row is 0. So a plus b to the power of 0 is 1. What's the entry for row 0? It's also 1. It means the coefficient, there is only one coefficient, which is 1. Second one, a plus b to the power of 1. The number of row is 1. And what's the coefficient, what's the entries for this one? It's 1 and 1. So what are the coefficients are here for a plus b to the power of 1? 1 times a plus 1 times a. As you see, the coefficients are 1 and 1. How about a plus b to the power of 2, a plus b complete square, and is equal to a square plus 2ab plus b square. If you expand it, you will get this. And what are the coefficients? 1, 2, 1. So what's the row? Row is 2, and what are the coefficients? It's 1, 2, 1. And again, as you see in here. And how about a plus b complete cubed, or a plus b to the power complete to the power of 4? It's equal to, if you expand it, you will get a to the power of 4 plus 4a cubed b plus 6a square b square plus 4ab cubed plus b to the power of 4. It means if you multiply a plus b 4 times by itself, you will get this one. This is the expansion of this binomial expression. What's the coefficient in here? 1, 4, 6, 4, 1. It means if the power is 4, so the entries related to the row 4 are the coefficient of that expansion. It means 1, 4, 6, 4, 1, or in here, as you see in Pascal triangle, 1, 4, 6, 4, 1, or the coefficients of a plus b to the power of 4 binomial expansions. So we can generalize that the binomial expansion, the Pascal triangle, or the entries in Pascal triangle, are the coefficients of binomial expansion, or the coefficients which we get in binomial expansion, a plus b to the power of n. So we can also say that the properties of expansions of binomial expressions to the nth power. The first property is there are n plus 1 terms. For example, if we have a plus b to the power of 10, so the expansion has 10 plus 1, or 11 terms. Second one, the coefficients of the terms in expansion can be obtained by what? By entries and binomial expansion, which related to nth terms. If the power of binomial is n, so the entries belongs to n, and in Pascal triangle is also the coefficient of that binomial expansion. For example, if we have 2x plus y to the power of 8, so the entries belongs to row 8, or the coefficients of that binomial expansion. Third one, the power of the first term in binomial expansion starts with the power of the first term in binomial expression starts with n and decreasing 1 by 1 in each term. For example, if the power of binomial is 7, so the power of the first term will start from 7, and the next term the power will be 6, and in the next term the power will be 5 and 4 and 3 and 2 and so on, like this. Okay, how about the power of the second term in binomial expression? The power of the second term starts with 0 and ends with n. The power of the first term starts with n and ends with 0, but the power of the second term starts with 0 and it decreases 1 by 1 up to n. You will see it in some examples. In the expansion, the fifth property, in the expansion of x plus y to power of n, the sum of the exponents of x and y is always n. As the power of the first term is decreasing 1 by 1, the power of the y or second term is increasing 1 by 1. It starts with n, is the second power, or the power of the second term starts with 0, so n plus 0, n. So the power of the first term is also n. And the second, in second term, the power of x will be n minus 1, the power of y will be 1. So n minus 1 plus 1 is also n. And so on. If you go to each term, you will get the degree of that term as n. The sixth property, the sum of the coefficient of an expansion can be found by substituting 1 for each variable. If you substitute 1 for variable, it can be a, b, x, y, anything, you will get the sum of the coefficients. But if you want to find the constant term in a binomial expansion, so you should substitute 0 for variable. It will make all the terms which has variable 0, and what will be left? The constant term will be left. There is an example. The example says that how many terms are there in the expression of x plus y completed to the power of 12. As you see in here, n is equal to 12. So we say that if n is equal to 12, how many terms in expansion do we will have? We will have n plus 1. So 12 plus 1 or 30 will be the total number of terms for this binomial expansion. As we study the properties of binomial expressions or expansion of binomials, so we can expand any binomial using Pascal triangle. As you see in here, we have a Pascal triangle. Let's expand 2x plus y completed to the power of 4. First of all, by using Pascal triangle, we can find the coefficients of this binomial expansion. What are the coefficients? As you see in the row 4 in here. So what are the coefficients in here? 1, 4, 6, 4, 1. It means the coefficient of first term will be 1, the second term will be 4, and the coefficient of third term will be 6, fourth term will be 4, and the fifth term will be 1. Let's expand it. 2x plus 4 plus y, completely to the power of 4. And it's equal to. We said that the first, by using Pascal triangle, the coefficient of first term is 1. And the power of the first term starts with what? With n. What's n in here? 4. So the power of the second term starts with 0, so y to the power of 0. And the power of the first term is decreasing 1 by 1 in next terms. And the power of the second term, I mean y to the power of 0, will be increasing 1 by 1 in next terms. Plus, the second coefficient is 4 times 2x. In here, the power of 2x was 4 in previous term. So in this term will be 3. And the power of y was 0, and this term it will be 1. Plus, again, 6 times 2x to the power of 2, the power of 2x is decreasing, and the power of y is increasing. Y was the power of y was 1, and in here it becomes 2, plus 4 times 2x to the power of 1 times y to the power of 3, plus 1 times 2x to the power of 0 times y to the power of 1, I'm sorry, 4, and it's equal to y to the power of 0 is 1, and 2x to the power of 0 is 1. Let's simplify them. 1 times 2x to the power of 4 is 1. We do not need to write 1 again. 2x to the power of 4 is 16. I'm sorry, x to the power of 4 plus 4 times 8x cubed y plus 6 times 2x complete square is 4x square y square plus 2x 4 times 2x, I'm sorry, 2x, 4 times 2x times y cubed plus 1 times 1 times y to the power of 4, and is equal to 16 x to the power of 4 plus 32 x cubed y plus 24 x square y square, I'm sorry, plus 8xy cubed plus y to the power of 4 is the expansion of this binomial expression. Let's solve the b section, n plus 1 over n completed to the power of 5. Let's expand it. By using Pascal triangle, we can expand it. N plus 1 over n completely to the power of 5. And it's equal to, what are the coefficients for power of 5, or f n equal to 5? So we look at the entries related to rows 5 or 5, row 5. The entries are 1, 5, 10, 10, 5, 1. And at the same time, it's the coefficient of this binomial expansion that we are solving, or we are expanding it right now. So 1 times the first entry, first term is n to the power of 5 times 1 over n completely to the power of 0. Again, as we solved in the previous example, or we expanded the previous example, plus 5 times the power of n is decreasing 1 by 1, and the power of 1 over n, or second term, is increasing 1 by 1, plus the third coefficient is 10 times n to the power of 3 times 1 over n to the power of 2, plus again 10 times n square times 1 over n cubed, plus 5 times n to the power of 1 times 1 over n to the power of complete to the power of 4, plus 1 times n to the power of 0 times 1 over n completely to the power of 5. Let's simplify them. So it's equal to 1 over n to the power of 0 is 1, and n to the power of 0 is 1. 1 times n to the power of 5 times 1, n to the power of 5, plus 5 times n to the power of 4 times 1 over n. 1 over n complete to the power of 1 is 1 over n, plus 10 times n cubed times 1 over n square. 1 over n complete square is 1 over n square. 1 square, 1 over n square, plus 10 times n square times 1 over n cubed. 1 over n completely cubed is 1 cubed, or 1 over n cubed, plus 5 times n times 1 over n to the power of 4, plus 1 over n to the power of 5. 1 over n to the power of 5. Let's again simplify them. So it's equal to n to the power of 5 plus, n to the power of 5 plus 5 times n to the power of 4 times 1 over n is 5 times n to the power of 3. If we simplify n to the power of 4 and 1 over n, we will get n cubed, plus 10 times n cubed times 1 over n square, 10 times n, because square and cube will cancel. So 10 times n, plus again n square and n come plus 10 times 1 over n, plus 5 times n times 1 over n to the power of 4 is 5 times 1 over n cubed, plus 1 over n to the power of 5. Or let's write it a little simply. N to the power of 5 plus 5n cubed plus 10n plus 10 over n plus 5 over n cubed plus 1 over n to the power of 5 is the result of this binomial expansion. In this example, the question asks us that find the sum of the coefficients of this binomial expansion, 3x plus y squared completed to the power of 5. For finding sum of the coefficients, we said that we substitute 1 for variables x and y, for example here. So let's substitute 1 for x and y to find the sum of the coefficients. It means x and y, both of them are equal to 1. Equal to 1. So 3 times 1 plus 1 square completely to the power of 5, and it's equal to 3 times 1, 3, plus 1 square, 1. So 3 plus 1 is 4 completely to the power of 5, and it's equal to 1024. So what's the number sum of the coefficients of this binomial expansion? It's 1024. In this example, the question asks us to find the constant term in this expansion, say 1x plus 3 completed to the power of 5. In previous example, we said that for finding the sum of the coefficients, we equalize or we substitute 1 for variables, or we equalize the variables as 1. In here, for finding constant term, we equalize the variables as 0, or we substitute 0 for constant terms. So let's find the constant term in here. So we have one variable in here, x is equal to 0. We equalize it as 0. We substitute 0 for x. So 7 times 0 plus 3 completely to the power of 5, and it's equal to 7 times 0 is 0. 0 plus 3, 3 completely to the power of 5, or 3 to the power of 5 is 253. What's the constant term in here? It's in this expansion, 7x plus 3 completely to the power of 5. If you expand it, you will get 243 as constant term. Check yourself. 13 is your homework in your books. You should solve it. If you have any problem or question, so contact us with our school WhatsApp number, and you will get your response by the same number. Thank you for your attention.